Okay, today we want to look at the concept of Coulomb's law. Coulomb's law explains the attraction or repulsion of two electrically charged objects. Please remember when talking about Coulomb's law, the two objects that are the same charge will repel, two objects that are of a different charge will attract. We started getting into this law a little bit in class today, and now we want to really look at this law and look at some sample problems. Coulomb's law. The equation for Coulomb's law is going to be F, the force of attraction or repulsion, equals K, a constant, times Q1, the charge of object 1, Q2, the charge of object 2, divided by the distance between them squared. Q in this case is going to be charge in the unit of coulombs, which is capital C. R will be the distance between the charges. K is a constant. It is always the number 9.0 times 10 to the 9th. And F we know is force in newtons. This is incredibly similar to Newton's law of universal gravitation. F equals big G m1 m2 over r squared. Looks identical as an equation with different variables. The constants is the huge difference here. Constant for Coulomb's law, 9 times 10 to the 9th. Constant for universal gravitation, 6.67 times 10 to the negative 11th. But the solving of problems is going to seem very similar, so let's jump right in to solving problems. I do highly recommend that when doing these problems, you first read the problem, press pause, try it yourself, and then press play again to see if you've done it the same way that I have. A negative charge of 4.0 times 10 to the negative 4th coulombs and a positive charge of 6 times 10 to the negative 4th coulombs are separated by 0.5 meters. What is the magnitude of the force between these charges? Is it attractive or repulsive? So we're solving for force. F equals K, Q1, Q2 over r squared. So now let's plug in the values we know. 9.0 times 10 to the 9th. Q1, it doesn't matter which charge we call Q1. I'll just do the first one that was listed. Times 10 to the negative 4th. Q2, 6.0 times 10 to the negative 4th. And R, 0.5 meters squared. Multiply 9 times 10 to the 9th by 4 times 10 to the negative 4th by 6 times 10 to the negative 4th. Divide that answer by 0.5 squared. That will give us our answer in this case. Relatively large answer of 8,640 newtons. And the question, is it attractive or repulsive? Since we have a positive and negative charge, it is attractive. Okay, let's try another one. Two equal charges of magnitude 1.5 times 10 to the negative 7 coulombs experience an electrostatic force of 7.5 times 10 to the negative 4th newtons. How far apart are the center of these two charges? So force equals K, Q1, Q2 over r squared. In this case, the force, 7.5 times 10 to the negative 4th equals 9 times 10 to the 9th times 1.5 two of these, so I can just call it squared over r squared. Now it becomes a little bit of math. I would divide both sides by 9 times 10 to the, or I would cross multiply first, actually. Let's cross multiply first. I think that's easiest. Multiply 9 times 10 to the 9th times 1.5 times 10 to the negative 7th times 1.5 times 10 to the negative 7th. We get 2.025 times 10 to the negative 4th. Then divide both sides by 7.5 times 10 to the negative 4th. I get r squared equals 0.27. Then take the square root of that. R was 0.52 meters. A little bit harder algebra here, but not much different of a problem. Lastly, let's look at a little bit more complicated problem. Two charged spheres, 10 centimeters apart, attract each other with a force of 3.0 times 10 to the negative 6 newtons. If one sphere has twice the charge of the other sphere, what is the charge of each sphere? So F equals K, Q1, Q2 over R squared. 3.0 times 10 to the negative 6th equals 9 times 10 to the 9th. I don't know the charge of either of these, so I'm going to call one charge X, and I know the other charge is twice as large, so I'm going to call it 2x. And I know these charges are separated by 10 centimeters. This needs to be in meters, so 0.1 squared. Now, the first thing I would do in this case is multiply both sides by 0.1 squared. If I do that, I get 3 times 10 to the negative 8 plus 9 times 10 to the 9th. X times 2x, 2x squared. Now divide both sides by 9 times 10 to the 9th. I get 3.3 times 10 to the negative 18th equals 2x squared. Divide both sides by 2. 1.67 times 10 to the negative 18th equals x squared. Take the square root. I get x is equal to 1.3 times 10 to the negative 9 coulombs. Therefore, the other charge must be 2x. So 2 times this, 2.6 times 10 to the negative 9th would be the other charge. If you have any questions, please bring them with you to class tomorrow.